So welcome to Unit E. We are moving away from algebra for the remainder of this course, and Unit E is all about rates, rates and ratios, honestly. A lot of this is more practical in our lives, and we're going to get into it in our introduction, talking about rates and ratios. So they are related. They're similar in ways. A rate, what we're talking about, is a ratio between two related quantities in different units. And so what we're talking about, an example of this, sometimes I find that useful in math or in anything, speed, right? Speed is a rate of travel. So 20 kilometers per hour. They're in different units. So we have our distance and our time. It's a ratio between the two, but we call it a rate because they're in different units. The other one that we have are ratios. So ratio is a comparison of two numbers or like quantities. They're usually in the same unit, so it's often no units. It's usually whole numbers. And so again, an example of this is if you make rice, you know that it's a 2-to-1 ratio. And you could talk about 2 cups, you could talk about 2 mugs, whatever you have in your kitchen, right? But these are 2 parts to 1 part. So 2 parts water to 1 part rice. And that's my classic example of a ratio. So you know what rates are and you know what ratios are. The way we write ratios in math is variable. So you talk about a 2-to-1 or an A to B ratio. You could talk about it as 2-to-1, which is what I did over here. Or you could also talk about it as a fraction. And so you could talk about it as 2/1. And so hopefully by this point, you're developing some familiarity with fractions. Certainly when we dealt with slope, it's a very functional way to see numbers as fractions. And I think that the same is true when it has to, when it's related to ratios. So ratios should always be in lowest terms. You could say it's 4 parts to 2 parts, right? Or it's just 2-to-1 as a whole number ratio. So write a ratio as a fraction. It's somewhat arbitrary. Usually if it's parts of water to rice, you just list how many parts are in water and then how many parts are in rice. So the first number is the numerator and the second is the denominator. So 3 to 5 is 3-to-5. They're just in order of the way they are. So let's try some of these ones. So a basketball team wins 17 out of 29 games in its season. Write a ratio of wins to games played. So we want wins to games. So it would be 17 to 29, or 17 out of 29, or 17 to 29. Either way, whether it's a fraction or as the dot dot ratios, either are fine. Now it says, right, the ratio of wins to losses. We know that there's wins are 17, but the losses would be 29 minus the 17, right? These are the games and these are how many they won. So you get a total of 12 losses. So 17 over 12 or 17 to 12, wins to losses. Ratios, when they're used to compare like quantities, so quarts to quarts, centimeters to centimeters, apples to apples, the ratio is simplified by canceling the units. So here we have a rectangle, and we want to write the ratio of width to length. So width to length, somewhat arbitrary on that. So the width would be 7 centimeters, and the length, this is in the wrong unit. So this would be 19 centimeters, right? If I can make them in the same units, that's how we like our ratios to be done. And so they would cancel and the whole number ratio would be 7 over 19 or 7 to 19. We could do it the other way. So length to width would just be 19 to 7. Or if you really like it in fractions, you can do it. If you can make the units the same, you'll find a whole lot in the homework. So in your blue homework pages, there are several where you have to make the units the same. Oops, sorry, several. Okay, so watch that. If you're getting your answers wrong, that's probably going to be the hang up when you do your assigned questions for this section. So let's try some more. We have a common size for a movie screen. It's 23 to 18, or sorry, 32. Oh my goodness, flipping numbers. 32 to 18. Nothing wrong with that, but it's not in lowest terms. It's whole numbers, that's great, but we do need to reduce this. And it's also in feet over feet. I should always write it like that. They cancel. If I divide the top and bottom by 8, or how about by 2? Not by 8. We'd get, what is that, 16 over 9. And so it could be 16 to 9 or 16 over 9. So we had our units the same and we want to reduce it to lowest terms, so as the simplest terms. So computer monitors are 640 pixels by 480 pixels. You might be able to change the ratio on your TV or monitor, right? That's something that we've done. Now this is not in lowest terms. You could, well, I didn't do this in one fell swoop. I divided both by 20, right? The units are going to cancel because they're the same. And what did I get? I got 32 over 24. And then I divided both by 8. I didn't know that they were both divisible by 160, which is the way we've always done fractions. You can take it little by little, stepwise, right? So it's a 4 to 3 ratio or a 4 to 3 ratio. Okay, so honestly, whole number fractions are whole number ratios, or whole numbers in fractions are the most useful way to represent ratios. Sometimes you get fractions in those. So we can deal with these one of two ways. We can deal with them as mixed numbers, right? Changing them to improper fractions and then divide, or we can often write the fraction as a decimal and then carry on from there, okay? So I'm going to do this one of two ways. You can choose which way you like better. So we've got Lauren and Carrie, right? And we want to write the ratio of the two distances that they putt their golf ball as a whole number ratio. So we'd have 22 and a half to 30. This is going to be the fraction way. So I would write this as a whole number, or as a improper fraction. So it'd be 22 times 2 is 44 plus 1, so 45 over 2. And that's all divided by 30. So you write it as an improper fraction and then just divide it. So that would be 45 over 2 divided by 30, which is 30 over 1. Anytime you're dividing fractions, you flip and multiply. I'm going to do this a bit sneaky. You might not do it this way. I divide both by 15 to reduce that. You could multiply across the top and across the bottom and then reduce, but I get an answer here a little bit quicker of 3 over 4, or a whole number ratio of 3 to 4, if you like it. So the other way, remember I gave options, and you might honestly choose this way, is write it as a decimal. So I could write it as 22.5 over 30. I want these as whole numbers. So the first thing I'm going to do is multiply the top and bottom by 10 to get rid of the decimals. So then I get 225 over 300. It's writing equivalent fractions, kind of the reverse of reducing them. And now I could reduce it to whole numbers, right? If I divide the top and bottom by 75, I just snuck a peek at my work. I didn't do this in one fell swoop. I honestly did it by 25 and then by 3. But you can get this down if you divide both the top and the bottom by 75 to 3/4. So you get to the same whole number ratio regardless of the way you go about it. And I'll leave it to you to decide. Do you want to do it fraction wise or do you want to do it decimal wise? I think most people like the decimal because it's a little bit easier and you can do more calculator skills with that. So the last one on the page here is a good example of this, and you can do it either, oh, sorry, not the next one. The last one is a good example. You can do it either way. So we've got this next one here where we've got a diameter of a 20-ounce bottle, which is 2.8 inches, over a 2-liter bottle, which has a diameter, again in the same units, of 5.25 inches. So what we're supposed to do is write that as a whole number ratio. So the inches are good, right? They go away. If we do this one decimal wise, because I think that one's easier than converting these decimals into fractions, right? We would multiply by 100 top and bottom because that would get rid of all of our fractions. So I get 280 over 525. And this makes nice, neat whole numbers that I can now reduce. I reduced both by 5, and I got 56 over 105. And it took me a minute to figure this one out, but I divided both by 7, and I got down to my answer, which is 8 over 15, or 8 to 15. So the last one is written as fractions. You can write those, do it fraction wise, or you can do it decimal wise. In the answer key, I did it the fraction way and the decimal way. I'm going to go ahead and do this the decimal way because I feel like that's probably the preferred way. So we've got Rita to Yi, right? They're jogging. We've got 3.5 for Rita and 4.25 for Yi. If I do this, oh, sorry, and they're both in miles. I always drop that one. Actually, I had to go back and write it all in my key to make sure that I was being consistent with that. Okay, so in this one, if I multiply the top by 100 and the bottom by 100 and then reduce, I can get this down to the easiest whole number ratio in lowest terms. So I'd get 350 and I'd get 425. I'm going to reduce them both by 25. I looked at my answer key on that one. You could do it by 5 twice if you wanted to, nothing wrong with that. And I get down to 14 over 17. So same with fractions. I know that 17 is a prime number, so that I'm good, right? I can't go any lower. They don't share a common factor. And so I could say 14 to 17 or 14 over 17. That's the lowest whole number ratio for the distances that Rita and Yi jogged. So these are all ratios, right? The first unit here is about rates and ratios. So the next examples are going to be more about rates. So rates, if you remember, my classic example was rate of travel or kilometers per hour. So your rate of pay is also something. You know how much you make an hour. That's your rate of pay, right? So if we want to figure out a rate of pay, if you make $136 in 8 hours, right? If I did the math on this, and calculators are handy on this, you get $17 per hour. That is your rate of pay. If you walk 8 kilometers in 2 hours, technically that is a rate, but we usually do the math on this and convert it down to 1 hour. So that would be 4 kilometers an hour that you travel at. There's a lot of rates in our world, and sometimes how you portray them can actually be really useful. So there's different ways. So rates can be expressed in a variety of ways depending on what we want to represent. So these two people work at a pizza place, and Carl can make 2 pizzas in 5 minutes, and Jesse can make 5 pizzas in 12 minutes, right? From that information, it's really hard to compare their rates. And so all of these are possible ways of representing rates. You'll notice that there's more in the homework for this. It's actually more in E.2, I think, but that's okay. How many minutes per pizza does it take? So what we can do with this rate is flip it the other way around, right? If we want to know how many minutes per pizza, minutes per pizza, we can flip the rate around. So that's 5 minutes for 2 pizzas. So that means that Carl is making 2.5, or taking 2.5 minutes per pizza, right? If we do the same work with Jesse's number, we know that in 12 minutes, they can make 5 pizzas. So we figure out the rate in that way, and we figure out that Jesse is making pizzas at 2.4 minutes per pizza. And so this allows us to equalize this to compare the two rates. And so what we know now is that Jesse is faster. So there's definitely some options when it comes to rates and ratios, but they really are arguably something that's useful in our lives.